Hello students, welcome back to this lecture series of mathematical methods in physics or M.Sc. part first. Okay, in the last class we discussed about the Legendre's equation and its solutions. Today we are going to discuss generating functions for Legendre's polynomials and it denoted by the Pnx. Okay, so if we try to find the Legendre polynomial, so we want to expand the generating functions around the point that t is equal to 0 and the coefficients of t power n, that is nothing but the Legendre polynomial. Okay, so here I am consider the generating functions, that is g generating functions defined with the g and it function of x and t. Okay, and this x and t, these are the variable things. Okay, two variables. It is equal to 1 minus 2xt plus t square bracket power minus half. Okay, so this is generating functions for the Legendre polynomials. Okay, and this is also equal to when we expand this generating function around the t is equal to 0. Okay, so the coefficients of t power n in the series, that is Legendre function. So also we can write in the series form. So it is summations n is equal to 0 to infinity Pnx. Okay, this is a Legendre polynomials and that is coefficients of the t power n. Okay, so also we can write this generating function is equal to these things and this series. Okay, so if from this it is 1 minus 2xt plus t square, we can write 1 minus bracket 2xt minus t square, here is minus half and power minus half. Okay, so in this forms we can write, and we know the binomial expansions for these brackets. If we have the 1 minus y power minus n bracket power minus n, so these things we can expand by using the binomial expressions, and that is equal to 1 plus n into y by 1 factorial plus n into n plus 1 divided by 2 factorial into y square plus n into n plus 1 into n plus 2 divided by 3 factorials into y cube and so on. Okay, these expressions from the binomial we can write. So similarly, if here you observe, this is a 1 and this things is nothing but the y. Okay, okay, this is y and this is 1 and this is nothing but the n if we compare with this expression. So we can expand this thing. So 1 minus 2xt plus t square bracket minus half is equal to 1 plus n is here half, so that is 1 by 2 into y is 2xt minus t square divided by 1 factorials plus n into, so n is half and the n plus 1, half plus 1, so it is 3 by 2 into y square, so it is 2xt plus minus t square bracket square divided by 2 factorials. And the last, if I again write for this fourth terms, that is half into 3 by 2 into 5 by 2, because for this n plus 2, so it is half plus 2, it is equal to 5 by 2 into 2xt minus t square bracket cube divided by 3 factorials, okay, and so on. Okay, this expressions we can write from this binomial expressions. Now if I expand this bracket, that is 2xt minus t square bracket square and the 2xt minus t square bracket cube, so a minus b bracket square, by using this formula we can expand this thing. Okay, so it is 1 minus 2xt plus t square bracket power minus half is equal to 1 for the 1 is as it is, and if I multiply, so it is 2xt divided by 2 minus t square divided by 2, and here is 1 factorial, so multiply with the 1 factorials, okay, for this term. Okay, so I am not right for the 1 factorials, and for this, so it is plus 3 by 4 into, if I expand this, so it is 4x square t square minus 4xt plus xt cube and the t power, okay, divided by 2 factorials, okay, and so on. Okay, so I am not expand this third one. Okay, so it is now 1 plus 2xt minus 2xt divided by 2 minus t square by 2 plus, if I multiply with the 3 by 4, so it is 3x square t square, okay, divided by 2 factorials. Here is a 1 factorial, so okay, here is also 1 factorial, and the minus, it is x t cube three, and it is 2 factorials. The last term, that is 3t power 4 into 2 factorials, and so on. Okay, so this is, we have the expressions. Now if I take out the commons, that is like t square and the t cube, so if I take out the commons, 1 plus 2 and this 2 will be cancelled, so it is x into t by 1 factorials, okay, plus from these 2 terms we can take out the common, that is t square, so it is plus 3x square minus 1 and t square divided by 2 factorials, okay, and again if we need to expand these things for the t cubes, okay, so this up to the 3 terms, 1 plus x into t by 1 factorial plus 3x square minus 1 t square by 2 factorials, and next for the t cubes. Okay, so this is expansion for the 1 minus 2xt plus t square, that is nothing but the generating functions of the Legendre polynomials. Okay, okay, so now this series we can, if I write in the expansion form, so it is p naught x plus p1 x into t plus p2 x into t square plus p3 into x into t cube, and so on. Okay, so this is one expansion of this things. Okay, so this is equal to generating functions, and what we derive this is also equal to the generating function. So if I give names, this is equation number first and this is equation number second. So from equation 1 and equation 2, if I compare, so we can write P naught x is equal to 1, P1 x is equal to x, and P2 x is equal to 3x square minus 1, okay. And here is 1 factorial, here is a 2. Okay, so this P naught, P1, P2, this is nothing but a Legendre polynomial of these Legendre's polynomials. Okay, so these are the coefficients of the t. Okay, so t power 1, t power 2, t power cube, like that. Okay, so this is a Legendre polynomials. Okay, so by the definitions, first I told already. So when we expand these generating functions, these things are around the point that is t is equal to 0. So coefficients of t power n, that is nothing but the Legendre's polynomial. So these are the coefficients of the t power n. Okay. Okay. So next, let's discuss some properties of the Legendre polynomial. Okay. First property, Pn1 is equal to 1. Okay. So here we know the generating function, that is g is a function of x and t, is equal to 1 minus 2xt plus t square minus power half. Okay, so here, sorry, one mistake. Okay, so generally polynomials we write like this, p in x. Okay, so this x is here 1. Okay, so x is equal to 1. So this generating functions, if I put the x is equal to 1 into the generating function, so g 1 is equal to 1 minus 2t plus t square bracket power minus half. Okay, and these things you can write 1 minus 2t minus t sorry, you can write minus t square minus t bracket square into minus half, or bracket minus half. Okay, so if I expand this thing, so same we can find, and this 2 and this minus half will be cancelled out, so it is 1 minus t minus 1. Okay, so this is, now we have the generating functions. Okay, if I put the x is equal to 1. Okay, so here power is 1. Now by using the binomial expansions, if I expand this thing, so g is 1 t is equal to 1 minus t power 1 minus 1. So if I expand by using the binomial expression, so it is 1 plus t square by 2 factorials plus t cube by factorial here is, because minus 1, so t square plus t cube plus t power 4 and so on. Okay, so this is the expansions of the generating functions. Okay, so we know the g x t, that is equal to n summation over n is equal to 0 to infinity p n x into t power n. Okay, So this, if these things, if I expand, so it is p naught x plus p1 x into t plus p2 x into t square and so on. Okay, so p naught, if I compare this expression and this expression, so p naught x is equal to 1. Okay, so this x is equal to 1, so it is p naught 1 is equal to 1. Okay, so is equal to 1. Okay, for these things. And if for the n term, if I write, so it is pn is a function of x into t power n. Okay, this is, and also here if you observe, that is t power n, this is 4. Okay, so coefficients of this t power n is equal to 1, and the coefficient of the pnx into t power n is this thing is a coefficient. So also we can write this pnx is equal to 1 from this. Okay, this is pnx, coefficient of the t power n, and this x is equal to 1, so it is pn1 is equal to 1. Okay, so this is first property of the Legendre polynomials. Now second one, pn minus x is equal to minus 1 power n into pn x. Okay, so this is the second properties. So in this pn minus x, this x generally x here, so this x is replaced with the minus x, is equal to minus 1 power n into pnx. Okay, so I am considering x is equal to minus x. Okay, so if I differentiate this with respect to the x prime, so it is dx by dx prime. Okay, okay, so it is equal to minus 1. X prime is equal to, one second, sorry, x prime is equal to minus x. Okay, this I am assuming. So we can write dx by dx prime. Okay, so it is minus 1. Okay, from this. Okay, so d by dx is equal to, that is dx prime, dx prime to dx and d by dx prime. Okay, like this. So I replace these things with the minus ones. Okay, this inverse is also minus, so it is minus 1 d by dx primes. Okay, so now d by dx is equal to minus 1. Here power of this minus 1 is 1. Okay, here d by dx. Now d square by dx square, so it is also equal to minus 1 power 2 d square by dx prime square. Okay, like this. And if I solve, that is d cube by dx cube is equal to minus 1 power cube dx cube by dx prime cube. Okay, so similarly we can write d power n divided by dx power n is equal to minus 1 power n into dn by dx prime power n. Okay, so these expressions, if I use in the Rodriguez formulas, so this Rodriguez formulas also give the relations of the polynomials. Okay, so we know the Rodriguez formulas. Formula for Legendre polynomial. Okay, so it is Pn x is equal to 1 by 2 power n into n factorials d power n by dx power n into x square minus 1 bracket power n. Let me check. Okay. Okay, so this is your Rodriguez formulas. Now in this Rodriguez formula, if I replace this d power n by dx power n with these things, okay, so and also I am replacing this x with the x prime, okay, so it is Pn x with the minus x, okay, so here let me, okay, I put the expression for the d power n by dx power n and replace the x with the minus x, okay, and also put the value for the d power n dx power n is equal to minus 1 power n into d power n by dx power n. Okay. So if I substitute, so it is Pn minus x, okay, Vx we replace with the minus x, 1 by 2 power n into n factorials. Now d power n by dx power n, it is equal to minus 1 power n d power n by dx, so dx we replace with the minus 1, so it is minus 1 x power n, okay, and minus 1 x power n minus, here is 2, okay, this expression. So we can write this is nothing but the Pn x, okay, so Pn minus x is equal to minus 1 power n and 1 by 2 n by into n factorials d power n by dx minus x power n into minus x bracket square minus 1 power n, okay, so these expressions we can write as a Pn minus 1 power n into Pn x, okay, okay, like this, okay, so this is Pn minus x is equal to, this is a second property of the Legendre polynomial, okay, so okay, we will stop here, we discuss in the next lecture.